Good morning. This is your stat sensei, Mr. Spensei, and we're going to go over a warm-up involving the inverse norm and the normal distribution. So at a college, the scores on the chemistry final exam are approximately normally distributed with a mean of 75 and a standard deviation of 12. The scores on the calculus finals are also normally distributed with a mean of 80 and a standard deviation of 8. All right, the fact that they're normal lets us know we're going to be working with some sort of normal distribution. And let's see what it has. This is what is the student's percentile ranking in chemistry. Off to the side, I just broke it down, recording chemistry, mean of 75, standard deviation of 12, and the calculus mean of 80, standard deviation of 8. And then I have his scores of the 81 on the chemistry and the 84 on the calculus. So what is the student's percentile ranking in chemistry? So let's draw a picture of that. And remember, percentile rankings start at negative infinity. Our mean was 75, but the student scored an 81. So he scored above the mean. So we're expecting a percentile ranking above 50% because we crossed 50%. Well, because they're asking for a percent, when you ask for a percent, you're going to do a norm CDF. The lower bound is negative infinity. The upper bound is 81. The mean is 75. And our standard deviation for chemistry was 12. So lower, upper, mean, standard deviation. So let's drop that into the calculator real quickly. So second vars, normal CDF. Second vars, normal CDF. Lower bound, negative 9 raised to the 99th power. Upper bound, 81. Mean is 75. Standard deviation of 12. And we come up with 69%. And that's definitely over halfway. So that's probably pretty reasonable. 0.6914. All right. The next one. What is the student's percentile ranking in calculus? Well, once again, percentile rankings start at negative infinity. So we're going to start off at negative infinity. And we have a mean this time of 80. And the student scored an 84, so he's over halfway again. We're looking for the area, we're looking for that percent, so this is going to be a norm CDF. The lower is still negative infinity. Our upper part of our shading, we shaded up to an 84. Our mean is 80. And our standard deviation is 8. So lower, upper, mean, standard deviation. Second vars, norm CDF, lower negative infinity. Upper this time is an 84. Mean of 80, standard deviation of 8. And we do that, we get 0.6914. Interestingly, even though the scores are different and the distribution is different, you have a different mean and different standard deviation, we answer C going, hey, which student did the student do better in relative to everyone in that class? The student did the same. Relative to the other students, or as compared. All right, what z-score represents the lower 15% on the calculus test? All right, so we're talking about a z-score, and we can't forget all z-scores have a mean equal to 0 and a standard deviation equal to 1. So it wouldn't have mattered if we were talking about the calculus test or the chemistry test. We would have gotten the same z-score. All right. So the lower 15%, so we're started at the bottom, and we go here. This is 0.15. And because they gave us an app, if they gave you an area percent or probability, that's where you have to do an inverse norm, because you're going to be looking for this value right there. So inverse norm, the very first thing the calculator is going to ask you for is the area, which is 0.15. Then it's going to ask you for the mean, which is 0, and our standard deviation is 1. So we'll label all that. That's our probability. That's our mean. And this is our standard deviation. And our shading, we started off shading on the left, so this is a left. And go second vars, inverse norm, area 0.15, mean is 0, standard deviation of 1. Make sure it's highlighted for the left. And you end up with a z-score of negative 1.03. So z equals negative 1.0364. All right, negative 1.0364. And we'll box that in, and I'll take care of that one. The next one, 30% of the students scored above what on the calculus test? All right, so we need the calculus test information first off. Well, we know it was normal. And if we look back above, we find that the mean was 80 and the standard deviation was 8. So let's write that down. Mean is 80. The standard deviation is 8. We draw that on the graph. All right. So 30% scored above what? Anytime they mention what, I usually say, let's make an X because we don't know what is. But 30%, oh, that means we're starting on the right. So we're starting up here. This is my 0.30, and we're looking for that value. If they give you a percent, a probability, or an area, if they give you the app, remember it's inverse norm. So inverse norm, they're asking for the area, which is 0.30. We actually are working with a calculus score, which is 80, and the standard deviation was 8. So percent, there's our mean, there's our standard deviation. Let's figure out what we get. Second vars, inverse norm, 0.30. Mean of 80, standard deviation of 8. And one thing we forgot to put, which direction am I coming from? Well, if I look at my graph, I started on the top, so I went from the right. So we started on the right side of the graph, so we need to go back and write that down and then make sure that we highlight right on the calculator. And we end up getting 84.19. 84.19. So about 84%. All right, this is your Stats Sensei, and I really appreciate you watching. See you on the next one.